might actually be okay with solving linear equations in one variable, but the total concept here, the general concept is you're going to simplify the algebraic expression on each side by removing grouping symbols. That's a fancy way of talking about distribution. Okay, so distribution is generally speaking how we're going to remove grouping symbols and then combining like terms. Then you're going to move everything to its own side. So all of the variables will go on one side and all of the numbers or constants will go on the other. You'll isolate the variable using inverse operations and solve. These are technically the skills you've known for forever. You just may not have known they're called that. This last little bit is important reminder that you can and should always check the proposed solution in the original equation by plugging it in. Now you have a calculator today, so plugging it in gets a little bit easier. On the notes, I'm going to have you plug it in and mental math it, but obviously you always have that resource there for you. So if we're looking at this first example, solving a linear equation, we see there are two grouping symbols. You have this grouping symbol and this grouping symbol. We want to get rid of both using distribution. So we're going to go ahead and distribute the 2, and we're going to distribute the -3. To do that, 2 times x is 2x, 2 times -3 is 6. Then we drop down the -17, you drop down the 13. -3 times x is -3x, and -3 times +2 is -6. Do we understand distribution? Cool. The one thing about distribution where most students error is this little negative here. Please make sure that you distribute a negative sign if you need to. It goes to both. Now, from here, there's a varying number of ways you can solve this equation and mathematician's choice, but I'm going to show an aggressive amount of work right now just in case somebody doesn't understand what I'm talking about. What we're going to do is we're going to move all of the terms with variables to the left side. So this is a term with a variable, it's already on the left side. This is a term with a variable, it's not on the left side. To move it over here, what do I have to do? Plus 3x. Here's my thing. I don't need to see the little mini steps in between of plus 3x on both sides. If it moves from one side to the other and changes signs, I understand that you did inverse operations. If you need to show it, fine by me. Now we want to put all the constant terms or single numbers on the right-hand side. This is a constant number and it's -6 right now, so if I move it over there, what does it become? +6. How about the 17? +17. And then the 13 and the 6 are already on the correct sides. You can, again, show me the +6, the +17 on both sides. Or just, boop, drop it over there. So then, yeah, now we have everything on the correct side. We combine like terms. 5x, whoa, what? 2x plus 3x is 5x. I have a +6 and a -6. They'll cancel out, so that's easier than trying to add them. 17 and 13 is 30. And how do you get that x by itself? Divide by 5. Again, I don't need to see the little division bar. If you can do it without it, fine. If you need to see it, that's fine too. But clearly, if you go from 5x to x, I divide it by 5. Okay, cool. We think this is the solution, but because we don't have our check answer button ready to go and there's no like answer key for me to check, how do you check to make sure you have the right answer? You plug it in. So here's my plug-in step. You're going to take the 6 that we think is the answer, and everywhere there was an x in the original solution, you're going to put a 6 there. Now at this point, if you have a calculator, you put everything up to the equal sign in the calculator, press enter. Then everything on the other side of the equal sign, press enter. But let's mental math it. I know you have your calculators in your hand, but we're going to practice mental math because it's important. We just did a whole lot of PEMDAS work with your thinking task, which means we start on the inside. We'd have to do the 6 minus 3, which is 3. Drop everything else down. And then the 6 plus 2, which is 8. PEMDAS tells me then to do multiplication first, so 2 times 3 is 16. 3 times 8 is 24. 6 minus 17, what is that? -11. And then 13 minus 24? We really hope that it's what? And it is, hooray. And once we have confirmed that we have the correct answer, that's when we can confidently put a box around things and call it a day. Again, I know for the majority of this class there will be a check answer button, but when you get to tests, or maybe your TSI test or your SAT test, if you haven't taken that one yet, you can always check a solution by plugging it in. Questions, comments, concerns? Really pretty easy. Entry-level solving. Let's go to something a little bit harder where everybody panics because look, fractions. Equations are generally easy to solve when there are no fractions. So let's get rid of them first. I love fractions, but this is actually what I would do too when I'm dealing with this. We're going to multiply every term of the equation by the least common denominator. So we need to know what the least common denominator is for all of the terms in the equation on both sides. Because when you multiply each term by the least common denominator, or to create a least common denominator, the fractions will disappear. And it'll get way easier. It goes back to looking like number one. So question, what is the common denominator? Oops, I pressed the wrong button. What is the common denominator here for this problem? Yes, 12. Now here's the thing, and a lot of people forget this. Don't forget you're doing this for all sides, so that 2 is like 2 over 1. Did that change my least common denominator? No, it's still 12. So what I'm going to do is I'm going to create all of these fractions. There's 3 fractions in this problem now that I put 2 over 1, and I'm going to make them have the denominator of 12, meaning that was not supposed to be 2. This is going to have a denominator of 12, this is going to have a denominator of 12, and this is going to have a denominator of 12. I think most of us got to this question last class on those levels that I did, but for fractions, how do you get them to have a common denominator? Like, what am I trying to do here? How did I go from 4 to 12? Yeah. I know it's 12, but if I want to change 4 to 12, what did I do? Multiply by 3. So to show my work up at the top, and I recommend this especially when it's complicated, you're going to take whatever was at the top of that fraction and also multiply it by that number, 3. For that second fraction, what did I have to multiply the denominator by to get 12? 4. So I'm going to do the same thing on the top, again using parentheses because complicated. How about that 2 on the other side of the equal sign? What did I have to multiply its denominator by? 12. So just to show my work, I'm still going to do that number times whatever was there, which was just a cute little 2. Okay, cool, great, awesome. Now that they all have the same denominator, we can just deal with the numerators. Meaning at this point, I can just pretend that this equation says 3 times x plus 2 minus 4 times x minus 1 equal to, and I can't help myself, that's 24. 12 times 2. Denominator's gone. Because they're all the same, we're comparing them amongst the same kind of fraction, we can just deal with the numerators. Now this problem looks like the problem that was above, where we're gonna go ahead and do distribution and finish solving. 3 times x plus 2 is 3x plus 6. Negative 4 times x minus 1 is negative 4x, and then positive 4. Ooh, negative times negative is positive. Following the steps from above, we get all the x's on one side and everything else on the other side. So if I'm showing a massive amount of work, this is what I would do. This becomes negative 6, negative 4, and then I have my positive 24. Do we follow what I just did? Took the constants to the other side, cross the line, change the sign sort of situation from Algebra 1. 3x minus 4x, what do we get? Negative x. I won't put the 1s in front of x's. You can. I won't. Negative 6 minus 4, that's negative 10. Negative 10 plus 24 is what? 14. So we have one last step here. What is the last step to get x fully by itself? Divide by negative 1, which, again, I don't need to see that step. I don't need to see the fraction bar. But if you like to see it, put it. I'll let you check this one, and you can do it in your calculator instead of mental math. I want you to plug negative 14 into every place there was an x in that original equation to make sure that we have the correct answer. What'd you get? 2, which is exactly what we wanted because the other side just had a 2 there. We wanted that to be 2 so that we showed that it's a correct solution to this equation. We can confidently box our answer. Major questions, comments, or concerns for these two types of equations? Now that we've done linear fractions, we can start working with rational equations themselves. Now, rational equations kind of look like the problems we just did. However, there's going to be a variable in the denominator, variable appearing in at least one of the denominators. When that occurs, you are now dealing with a different kind of function, but we kind of attack it the same way. However, because there's a variable in the denominator, there becomes restrictions to the domain of that function, meaning there's numbers you can't plug into the denominator, otherwise the denominator will be 0. So for instance, in this example you can see right here, because this is a plain x, if I were to plug the number 0 in for x, that would be 1 over 0. Can you do that? No. And same here. 2 times 0 is still 0, right? So what we would say is that x cannot be equal to 0. That's a restriction for this function. It's very important when you're dealing with rational equations to always look at your restrictions first, because there's a chance that your function has no solution at all, because whatever was in the restriction is actually what you get when you solve it. And so then you have to like throw the answer away because it's not good. But other than that, we kind of attack these problems the same way we did the problem before this. So we're going to solve 1 over x equal to 1 over 5 plus 3 over 2x. Now we already know, because this is the example from above, that the restriction is x cannot equal 0. We also know that 2x cannot equal 0, but that just means that x can't equal 0 anyways. Now we need to know what the least common denominator is. Now we need a least common denominator that involves a variable, which is interesting. So let's look at the largest denominator or most complicated denominator, which in my mind would be this. Can x divide into 2x? Yes. Can 5 divide into 2x? No. So 2x can't be our least common denominator. We need to try to think of a denominator that will divide. Can anybody think of one? 10x, right? Because 5, 10, 15, right? 10 is an even number. So we're going to use our least common denominator as 10x. That means I want the denominator of every fraction in this problem to be 10. So for example, this needs to be 10x, and then this one needs to be 10x, and then this one needs to be 10x. What did I have to multiply x by to make it 10x? 10. So 1 times 10 is, don't overthink that, it's 10. Okay, cool. What did I have to multiply 5 by to get 10x? X, very good, 2x. So 1 times 2x is 2x. Notice this time I'm not showing that little multiply step because the numerators aren't complicated, but if there was a binomial up there, you would need to put it in parentheses so you could distribute. What did I have to multiply 2x by to get 10x? 5. So 3 times 5 is 15. Now that the denominators are all the same, you can leave them be. We're comparing the same fractions with the same denominator. So now we're just solving 10 equal to 2x plus 15. Easy peasy. This time, because there's only one x variable term, I'm going to leave it on the right side. I'm going to move the 15 to the other side. You don't have to show me this step if you can do 10 minus 15 in your head, but for a lot of us, we need to see it move and then we'll combine our like terms. But I just bloop, drop the 15 on the other side, change the sign. 10 minus 15 is negative 5. Divide by 2x. Again, I don't need to see that division step. If you like to show it because you want to show all of your work for yourself, that's fine. So we get negative 5 over 2 as our potential solution. First thing you do, is this the same number that we got here? No, we're good. So we can actually check our solution, because if we had gotten 0 as the answer, is x allowed to be 0? No, when we throw it away, it'd be called an extraneous solution. We are still going to check this answer. So in your calculator probably this time, because it's fractions within fractions, will you plug in the number negative 5 over 2 to every place there was an x? I'll give you some time to type because I know that's a complicated amount of fractions. Use that fancy fraction button if you haven't. Yes, so we said we checked it, so go put a little check mark for ourselves, and then boom, we know this is our solution. And it's not going to my TV. Catch up. Uh-oh. Come on, air server. Oh, she's gone. Let's do this with a little bit more of a complicated problem. Is that okay? Ooh, Hello, we have 3 over x plus 6 plus 1 over x minus 2 equal to 4 over x squared plus 4x minus 12. Again, the first thing we need to do is figure out the restrictions for this problem. I recommend also, if there's any squared terms, that we factor that denominator very first, because it will help us see what our restrictions are easier and what our common denominator is. Do we remember how to factor? I prefer you to guess and check factoring, but in Algebra 2 you probably learned the X puzzle method of factoring. We're doing an X puzzle in our head here though, if we're trying to do this with the guess and check method. We are trying to factor this. Since the X term does not have a coefficient, we can set up 2 parentheses where it's just X in the front. We need a number, 2 numbers, that multiply to 12 and will add to 4. So what are some things, just say them out loud, what are some things that multiply to make 12?
3 times 2.
Let's do this, never mind, don't just tell them all. Let's do it in an organized manner. 1 times 12, 2 times 4 times, 3 times, I just gave the answer away. Woohoo! Okay, so one of those pairings is going to add together to get 4. How can I make that happen? 6 minus 2, right? So if I do this, that means I'm going to have a positive 6 and a negative 2. 6 times negative 2 is negative 12. Check. 6 plus negative 2 is 4. Check. We factored it, which means that any number in the denominator that makes that denominator 0 has to go in our restrictions. There are only 2 restrictions for this problem, even though there are 1, 2, 3 denominators. Do you notice that these are the same? That's nice. There's just 2. Very nice, right? So what are the 2 numbers x is not allowed to be equal to? Let me show some work here so we can see how I'm doing this in my head. We know that the denominator cannot equal 0. That's the denominator, right? X plus 6. So what number can x not be equal to? Negative 6. In which case, if we notice a little shortcut here, this said positive 6, my restriction is negative 6, which means what's the restriction here? 2. It's always going to be the inverse sign of whatever you see in the factor, right? Factors and zeros are opposite signs. So we know that we can't answer the number 6, negative 6, or 2. We hope we don't get that as one of the answers, but now we turn to the actual problem. We need to create a common denominator. Here's what's nice about this, because we factored it. Remember how this is the same as this, and this is the same as this? That means this is my common denominator. Because we can multiply the other 2 fractions by the missing one to make the same denominators across. Here's what I mean by that. My first fraction is going to end up having the denominator x plus 6, x minus 2. My second fraction is going to end up having the denominator x plus 6, x minus 2. My third fraction already has the denominator x plus 6, x minus 2, and we know that because we factored it. See how I've set up now all the same denominators? Same way we did it when it was a simple denominator with just numbers. Same way we did it when it was a denominator with just an x. Okay. This fraction right here, what did I have to change about the bottom? What did I have to multiply the denominator by? Well, it already said x plus 6, so what did I have to multiply it by? X minus 2, which means I'm going to multiply the numerator times x minus 2. That's what was missing. So for the second one, what am I going to multiply 1 by? X plus 6, very good. And I know multiplying by 1 doesn't do anything, but so that we know we're doing the same thing each time, I'm going to show that 1. Do I need to multiply that last fraction by anything? No, because it already had that denominator. It's just a 4. And now, just like the other problems, because the denominators are the same, we can kind of ignore them because we can just compare the numerators. We only have one technical distribution here because distributing, oh, I forgot the one. Distributing a 1 is unnecessary. This is 3x minus 6 plus x plus 6 equal to 4. Do you notice something nice about this problem? Where we're at right now?
No, it's 0.
the 6's become 0, yes? Is that what you mean? Cool, which means I only have to add 3x and x, which is 4x. And thus, x is equal to what? 1. Now again, we would check our work to make sure that we got this right by plugging in that number. Oh, did we check our restrictions? Do we need to throw that answer away? No, we're good. I'll fast forward you through that part just because I know you can do it. This is the correct answer, so we can box our answer. But if you were on your own, taking a test or something, you can always check your work. So some of you ran across an interesting thing. If you made it to question 2 and 3 potentially, and this is like giving you a heads up if you hadn't gotten there yet, you got a no solution for questions 2 and 3, or you should have gotten a no solution for 2 and 3 when we're at the whiteboards. But that means that we have a different type of equation than normal, and we have some vocabulary to go over. An equation that doesn't have a solution, I'm jumping down to the third one, is called an inconsistent equation. Okay? For us, we found that it has no solution because it was part of the restrictions. But there are times when you're solving an equation and you eliminate all of the variables and you're left with an incorrect mathematical statement. So if we were looking at this, if you cancel out the x's, like subtract x to both sides, this would end up saying 0 equals to 7. Is that a true mathematical statement? No. So this is another instance in when you would say there's no solution because there's no way 0 is equal to 7. There is a symbol you can use for no real solution. It's called the empty set symbol. And I'm going to be real annoying about this empty set symbol because people write it incorrectly all the time. If you're a person who crosses your zeros, do you know what I mean by crosses their zeros? So like this business, this is a 0, check. A lot of people do this, check, that's still a 0. But the moment that your lines go outside of the circle, that is technically, in mathematics, the empty set symbol. So instead of saying that the answer is 0, you're telling me the answer is no solution. So be careful if that's part of your handwriting. I'm going to be picky about it. That's the empty set symbol. You're telling me something different. But that is a cool way to answer no real solution, empty set. Typical equations, the ones you're probably used to seeing, are always called conditional equations, meaning that there is one solution to those equations or a couple solutions to those equations, if you can actually answer the question. The third option is called an identity, and this happens when literally all of the solutions will work. So if you look at the example that we have, we see that there are x's on both sides, so if we subtracted an x over here, we'd end up with the mathematical equation that says 3 is equal to 2 plus 1, which is 3. That's a true statement, right? 3 is equal to 3. When that's the case, the textbook that we use uses set builder notation. You're probably way more used to seeing this. Do y'all know that symbol? What does it mean? All real numbers. So that's basically the same thing. You may see both. Your textbook may have you do this later on. Just know that this x, such that x is a real number, is the set builder notation way of saying all real numbers from negative infinity to infinity. Those will work. So let's just check and make sure we can identify these types of equations. Example 5 says to solve and determine whether the equation 2 times x plus 1 equal to 2x plus 3 is an identity, conditional equation, or inconsistent. We start solving the normal way, which means I do grouping. And I know a lot of people do their arrows to the top, but somehow I always end up doing mine to the bottom. I'm sorry. This is 2x plus 2 equal to 2x plus 3. I can already tell you this is a problem, right? Do you see the same amount of x's on both sides with the same signs? That means that if I were to move the x's to the other side, they would cancel out, and I'd be left with the mathematical equation 2 is equal to 3. Is that correct? No. No. So this is called an inconsistent equation, and we would answer with the empty set symbol, meaning no solution. Because that's just wrong. 2 does not equal 3. Not in this type of mathematics. Let's try another one. Example 6. So we have 4x plus 6 equal to 6 times x plus 1 minus 2x. Again, there's one more grouping sign. So boom, we're going to distribute. This is 4x plus 6 equal to 6x plus 6 minus 2x. I'm going to combine my like terms on that left side, right side real fast. This is 4x plus 6, and this becomes 4x plus 6. Whoa. I just said the same thing in a row, yes? If I canceled out the variables because they can go away, it's a mathematical equation that says 6 equals 6. Is that true? So this type of equation would be an identity. And we would answer that it has all real solutions, all real numbers as its solutions. So you're going to see that vocabulary asked for you. Conditional equation is the one where you can like straight up get an answer. So most of the ones we had done today were conditional equations. But then we had these few.